G'day guys, you're back with MiracleMAX. We're on location at the moment doing a mobile diagnosis of a Holden Rodeo 2006 with a V6 3.6 litre Alloy-Tech engine in it. Now I want to try and make it easy for you guys today to do a diagnosis, to break it down quick and easy. Let's get into it.
Max the mechanic is the man who fix it all. Yes, he can. With a joke and a cheer, your car troubles disappear.
The customer states that they had the engine running and then it just stopped. Now keep in mind there's three basic things that we need to make an engine run. We need fuel, we need air, and we need spark in the case of a petrol engine. So I'm just going to start with the basics first, and fuel honestly is a fairly simple one to do. Okay, so at this point we need to confirm the customer's complaint. Let's crank it over and see what it does. It's meant to be a crank no start situation. Well, that's a no crank at this point. Now, the customer did state that he had cranked it for quite some time, obviously trying to get the thing up and running. We'll chuck on the jumper pack and see if that helps, hey. Of course, you can see there that we have plenty of fuel in the tank, so it shouldn't be a supply issue if that gauge is telling the truth. I've had this PROJECTA jumper pack for some time, and it's a gutsy little thing, and it holds its charge for months and months and months. We're now in, let's go to the jump start position, so it's ready to jump start. Let's see if it cranks over for us. Okay, crank no start situation. Let's go under the bonnet and try something else. Just going to try and put some aero start or something similar down the intake system and see if that will start. That'll tell us if it's a fuel issue or if we need to search further. So a little bit of aero start down there. I can't show you guys because I've only got two hands. Okay, let's try again. See that? It went to start. So I'm heading toward a fuel issue. What's next? Okay, so under the bonnet now, right next to our battery, is our fuse box. Let's get that cover out the road. Put that to one side. Whoops. Now let's have a look at our fuse cover. We have a fuel pump assigned over here. You can see that. Where are we? Right there. It's our fuel pump there. And a fuel pump relay is this guy over here. Now I could check the fuel pump fuse over here, but I don't really want to. I'm going to go straight to the fuel pump relay. I'm going to pull that guy out and we'll have a look at some testing there. You can see this relay has two bigger pins, can't you? And then there's three little pins there. The two pins are the guys that provide the switch, I guess you could say. So we have power coming in and it goes power out, and it's switched on by an electromagnet by two of these other guys. Yes, there's three pins on this relay, but so you can see in the relay itself there's those two bigger pins up the top, and then there's only two pins on the side there. That's the coil. That's the one, the electromagnet that pulls the switch on. So all I'm going to do is that top pin and the one right below it, I'm going to bypass that with a fused wire, and then hopefully that'll tell us if we're going to have a fuel pump that works or not. So I'm on my negative side of the battery at the moment, and with my test light I'm just going to check for power there. So we've got power at that top one, so that'd be pin 30 right there, and that should go over to pin 87, and of course we don't have anything there at the moment. What we do need to check for the relay side of things, or sorry, the coil side of things, is to see if there is power over here and or over here when the ignition is turned on. I now have my test light on the positive side, so I'm looking for a ground at this point in time, and let's have a look down there and just push that down a bit further. Yes, we have a ground, so that pin on the right hand side is the ground. I believe that's pin 86. So over here, when the ignition is turned on, now it's a bit hard because by the time I get over here, I'm just putting that on the negative side of things. By the time I get into under the bonnet, then the light has gone out, but I should be able to see it when I turn the ignition on, just from the cabin itself. Right, ignition to the on position. And did that light go on? I couldn't see from here. We'll review that footage. So all I've done here is used a fused wire. I think that's a 20, is it? Yeah. And I've gone from pin 30 to my output of the switch, which is pin 87. Now at this point in time, this is making the fuel pump live at all times. Now we should have a noise at the fuel pump, a buzzing noise of course. Let's have a listen. But as you can hear, it's all quiet on the western front. So one trick you can do, if everything goes right, have a listen. Hear that? The fuel pump's now working. Right there is where the fuel pump's located. So I can get this thing up and running now and drive it back to the workshop. So fingers crossed it should start. Fuel pump stopped again, hasn't it? It's fine. Give it another pump. All right. Let's give it another shot. Right where that circle is by the looks. Like that. And there we go. Okay, back to the workshop to replace this faulty fuel pump. I'm now back at the workshop, made it safely, no breakdown. But I did notice on the way here that we've got a check engine light on, so whether that's been caused by me or we have a new issue, we'll have to look into that later on. I believe the fuel tank's got to come out on this sucker, probably easier than pulling the tray. I doubt I can get to it underneath, but we'll have a look and see what we can do to get that tank out and replace the fuel pump. Now I did diagnose this before, I wasn't being smart or anything, but I had diagnosed this before, so that I was able to order a fuel pump and fuel filter, etc. But I just want to show you guys how the process was done. Quick and easy. I was a mobile mechanic for 8.5 years, so I know a few of these techniques that got vehicles up and running fairly quick, and a quick diagnosis. Well, that certainly wasn't a 5-second job. I've got the tank out now, which was a bit of a pain in the bot. We were interrupted by a fire just a few streets over. Hopefully that's been sorted by now. In the meantime, I've been draining fuel out of the tank. It was pretty much full. I was also able to enlist the help of my motorbike stand lifting device, which I've used in many occasions for different things, particularly fuel tanks. Very, very helpful. The hoses aren't too bad to get off, to be quite honest. There's one located right up the front here. This is a return less system, so there's only one fuel line. And that connects onto this little pipe here, which goes through our fuel filter. Now, of course, I'm going to replace the fuel filter because we know the rules. We replace the fuel pump, we replace the fuel filter. Another guy that needs to be undone is that fella there. That's the vapor line that goes off to our carbon canister that's sitting up the top there. One of the hardest parts of this job was trying to access the clamps for these two hoses. This is our fill hose, of course, and this is our breather hose. You can have a look. See how brittle it is. It's got age cracks all over it. It's not very happy. And it was all dangling precariously off this mudguard bracket with an exhaust clamp, of all things. That's the two hoses that need to come off. The fill hose there and the breather hose. Now that breather hose is really, really brittle. Just doesn't want to bend, which made it quite awkward to get the tank out altogether. Have a look at the top of the tank there. That's where the fuel pump goes in. So I'll be cleaning that up meticulously before I head inside to replace the pump. And of course there's one electrical connector there. That guy there does the fuel pump as well as the gauge. To drain out that almost full tank worth of fuel, I just used a little clacker pump. And I've rigged it up so that I've got a filter in line, and you just shove that into the fuel that you want to pull out, and you just hook it up to a battery, and out the other end comes your fuel into your jerry can, wherever you want to put it. Okay, so I've done that. I've drained out, what's that, 20, 40, 60 litres worth of fuel just using this little clacker pump. So yeah, as long as the battery's charged, it doesn't take too long to do, and you can do some other jobs while you're waiting. So yeah, the tank's a lot lighter now than it was before, that's for sure. So here's a before shot of all the dirt and greeblies that are on there, and I'll give it a bit of compressed air, blow it all off so it's all nice and clean. So while not totally phantasmagorical, certainly a lot cleaner than it was before. I'll clean it up once again once I loosen this collar. That needs to be rotated that way, and blow under there because I don't want all the stuff going in underneath the O-ring, and I've got to get these connectors off as well. So it shouldn't be too much of a job, but yeah, cleanliness is the important thing. I was able to undo the collar simply by tapping here, you know, all the way around, evenly all the way around. It's got a little lumpy bumpy here that it needs to go underneath this collar down here, and so it's sort of, once you've over that, it's not too bad. Don't hit it here, but on this little bit here, just with a hammer and screwdriver I managed. So tapped over here, tapped over here, tapped over here, here, etc., etc. Getting these guys off here can be a bit of a pain in the bot. Basically, you squeeze them with your fingers. I have been using relay pliers, believe it or not. They've got a little 90-degree bend in there, so you can actually get onto these little blue things, press down hard, hey presto, press, 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 then you should be able to yank it off. Another thing I've done, you might notice, I've got a white texture mark here, a white texture mark here, two yellows, and one yellow, one yellow. So therefore I know how it goes back together. Don't want to screw it up before you put it back in. It was a pain to get it out. I don't want to have to pull it out again a second time. So once we've got all our pipes disconnected or marked and disconnected, then we can lift it up and it should come straight out. Now, these sort of wiggly snaky lines here catch on the side, and I reckon these are all original guys. They're definitely brittle, etc. And don't forget there's a sender unit on the side there that's got to come out, so we don't want to catch him. There'll be some fuel coming out too, so have a tray standing by like that. And come on fella, there we go, straight into my tray. We can tip him over. Goodness me, look at the dirt and stuff in there, guys. That's unbelievable. Can you see it? That's just disgraceful. Yeah, maintenance, mate. Never not. Let's have a look at the colour of the fuel coming out. It doesn't look too bad, but oh, there it goes. It's going a darker colour. You can imagine the bottom. Well, I'll disconnect it later, but you can imagine the bottom of this surge pot will be full of muck. You can see on the top of the pump there is full of gunky goos as well. And when I do my fuel filter, yeah, this has been maintained properly. I'm sure that'll be full of muck too. Of course, making sure that this O-ring is in good condition. It's not damaged at all. Looks okay. Oh, there's all dirt in it, mate. And even in these pipes here, I had to blow them out with compressed air because there was dirt actually inside the pipes. That's just not good. Got that ring area cleaned up nicely now. Had to scrape it all down and get some compressed air on it once again. I've had a look inside the tank and I thought, oh, well, that doesn't look too bad, but looking at it closer, not sure if you guys can see, but that there is dirt. And there's quite a few pockets of dirt in there. I might have to drain the whole tank itself because, yeah, that there is dirt. Not great. So I'll pull the fuel filter off next. I've got the filter out, as you can see, and this is the direction that it goes. So if we go that way, it should be nice and clean. But what's it been battling? Let's give it a bit of a shake and have a look at what comes out the other end. Check that out. That gives me an indication of what the actual fuel tank is like. Goodness me, check that out. So yeah, I'm going to drain the entire tank, blow this for a joke. It's just ridiculous. You can put in as many filters as you like. You're just battling uphill. Have a look at that in there. Man, that's disgusting. Yep, something to show the customer, I think. What do you reckon? Pretty rugged, hey? I've drained a good amount of the fuel, and what I thought initially was dirt, etc., it was actually staining on there. So whether it's had some water in there at some stage, but it's all gone. I had my hose down in there like a little vacuum and cleaned it up pretty well, and I can't see any other dirt, etc., so I'm happy with that. I've cleaned up this location here for the O-ring, apart from the dog hair, and I've also used some rubber grease on there. That's recommended for petroleum products, etc., O-rings, yada yada yada. So just helping it to reseal. I've cleaned all these hoses here, or the pipes here, the connections, etc. I've got my fuel filter, my new fuel filter in place as well. So I'm ready for my module, my new module to go in next, which is not very hard. We just stick our sender unit in there, our float, tilt it one way like a DOS, take it down, and of course we're going to face it this way where the pipes go, and make sure those wiggly worm fellas get out the road too. So that there should be about right, and that's spring loaded, of course. That gets pushed down once that rings on as well. So yep, that's all good. Connectors all the same, these are all the same. I've double checked all that. So it's in place. I just tap that collar around like I did before. Once you get past these little lumpy bumpy bits, it'll lock into place, and it just bottoms out against these other upright roundy things, I guess you could call them, the things that hold it down into place, the steel plate that holds it down, I guess, and this collar rotates to meet it. So yep, happy that I've got all my connections correct. My paint marks paid off. I've got them correct. Now I've just got to put it back in. When you put the tank in, it's a little bit difficult. This bit up here goes over a bracket that way, so there's a sort of a subframe assembly, and that has to go whoop, over the top of it, and then this fella over here is raised to meet it. It's a bit of a pain, I must admit. So you've got to really angle the tank, putting it in like this, get it over that bracket, and then you can lift it upright like that. So yeah, I won't show you because it's going to be too hard, but that's basically how you do it. Take it in on an angle, and then take it up with some sort of jack or something along those lines. Of course, another priority thing, don't forget to hook up your electrical connector before you put it up into place. So the tank's back in correctly with all its bracketry, etc. Bit of a pain getting this filler neck in. There's not much space between the cab and the tray itself. Anyway, have we fixed this starting issue? Is the thing going to start? Was it actually the fuel pump that was faulty? Okay, let's hit the key and see what it says. Oh, amazing. Of course, I've got to put all his fuel back in, bar the dirty stuff that I found. I'll just put the top half, I'll decant it and give him, you know, maybe half to 3/4 of a tank. Brushed DC motors are pretty much the same across the board. Of course, there's a few variations, whether they're in series, parallel, compound with our field circuit. So whether it's a power window motor, a radiator cooling fan, an EGR motor, an angle grinder, even a printer motor, or in our case, a fuel pump, even a starter motor. They're all constructed a similar way. Here we have our armature, and here we have our commutator. There'll be a magnetic field around it called the field coil. In this case, it's an electromagnet, whereas here in this particular fuel pump, you can see there's permanent magnets. This is broken up into individual windings, and they have brushes either side here. You can see the brushes on this particular motor here and over here. As this rotates, you can see that current would pass from one brush to another brush, and that would create a magnetic field. There's a separate magnetic field in this field coil here. If we have two like magnets facing one another, they want to push away from one another, don't they? If we put that on an axis, like this guy here, the whole thing wants to rotate. If we have a look at our armature off of our angle grinder, this is what I suspect we will find as a fault on our fuel pump. If you have a look at the commutator here, this is where the brushes rub against. Notice this section here, you can see it's burnt out, can't you? This is what I suspect we'll find on our fuel pump as the fault. Either that or there will be very weak brush contact. In other words, the brushes have run out of length. They don't have any tension against them anymore. They have springs behind them to push on to the commutator itself. But I think on the fuel pump, when we pull it out, we'll find burn marks here, or as in this case, a problem with the commutator itself. Well, look, I'm not sure I've made the right call here. Perhaps I got a bit excited. Check it out. It's just totally full of rust. Oh, goodness me. The sock would be absolutely chockers full of, you know, rust, etc. This is all rust. He's had water in the tank. Now, when I had a look in the tank, obviously, like I said, I thought there was stains, etc. But there was no water in there, so I was happy with that. But I'm going to pull this pump apart just to show you guys what's it like inside, and to give you an idea of the correct diagnosis. Once you've got the data, you've got to follow that path through, because, you know, obviously the answer is according to what the data provides to you. And this guy obviously has been pretty sad for some time. I had to physically break the module apart. It's not designed to be pulled apart and a pump to be replaced, but hey presto, I'm glad to replace the whole lot. Goodness me. That's what happens when you don't maintain your vehicle properly. Yeah, you mightn't use it very often, but hey, if you don't replace the filter on a regular basis, if you get fuel that sits there and goes stale, this is obviously, there's been water in with the fuel, so it's been, maybe it was even before he bought the vehicle, I don't know. But maybe it was a farm vehicle and they put, you know, dirty fuel in the from a farm tank or something along those lines that had water in it. I don't know. Either way, we'll pull that apart further and have a decent look at it. In true MiracleMAX style, I've decided to dissect the offending member. I cut through here with a Dremel just to pull it apart, of course. And we've got our typical standard electric motor, DC motor. We've got in here, hang on, I'll have to get some pliers. So we pull out our what's called the armature. We have our field magnets in there, they're permanent magnets. If you don't have to have a close look to see how much rust is in there, it's disgusting. All right, so we've got our armature. And on the side here, we have what's called the commutator. On this side here, we have the brushes. These guys here contact the electrical connector here, which should in fact just pull out like that. You can see our electrical connectors here. Looks like it's got a little capacitor across there, I would assume, just to stop any fluctuations of voltage. The interesting thing in this case in particular is what's called this commutator guy. Now if we have a close look at it, a really close look, hang on, I'll zoom in for you. Yep, there we go. You can see there's straight cuts through here, and that contacts this wiring going through the armature itself. Now if we have a close look, we can see there's several sections here where there is a dark spot. Can you see that? There's one over here, there's one over here, there's one over here. So what happens is when the brushes contact that point there and they get to a certain point, it has no continuity. In other words, it's an open circuit. You kick the tank, doink, like that, just enough to jiggle it like that, and then it can go into the next section of the armature, and of course then the pump starts to rotate. Of course, I also believe, which is kind of obvious in this case, the rust would have made a huge issue to the actual running of this. Now, if I'd been smart enough, I would have fired up the picoscope while this was actually running and taken a waveform to give you an idea of what it would look like. Now, on a waveform, we would typically see something along these lines. We would see current coming up and down, up and down. And when there was a dodgy spot, you'd probably find it low like this and then up and down like that, something along those lines. Needless to say, this is purely through lack of maintenance. Look at the rust build up on the side there. That's atrocious. All in all, it was kind of easy to diagnose this here fault with the fuel pump, but quite involved to replace the component because the tank had to come out. Anyway, it's about 3 weeks later. Customer was really happy with it, started every single time, so the diagnosis proved true. I hope that simple diagnostic process has given you a direction next time you come across something similar. If you felt fueled up and primed by this video and you haven't already, please subscribe to the channel, give it a like, feel free to comment down below. Of course, don't forget about that notification bell. You don't want to miss any future videos. Hey, check us out on Facebook as well as Instagram to see what's happening both in the workshop as well as the electronics lab. In the meantime, surf through the channel. There might be some other videos that interest you. So until next time, guys, this is MiracleMAX signing off. I will catch you later.